Alright, so just to wrap up my iterative algorithm set, I just wanted to do a couple of these ones where they kind of give you the algorithm written out like this, and also just because this is a tiny bit different to previous ones. But basically, when converting this to like the normal algorithms, the only thing here that's special at all is kind of here they've actually gone from I equals 0 to n over 2 minus 1, rather than traditionally from I equals 1 to n over 2. That makes absolutely no difference. And here they're just doing 3 basic operations instead of 1. So if we wanted to write this out in our sum notation, and I'll actually do it both ways just to kind of show how much it doesn't matter. But if we have I equals 0 to n over 2 minus 1, and so the difference here is that we're doing 3 each time, right? So this is the number of iterations. Every iteration we do 3. Each of these is a basic operation. This is the cost of our function, or our algorithm. So super simple here, since 3 doesn't depend on I, if you remember kind of our formula that I equals L to U of C A I is equal to I equals L to U of A to the I C. You can kind of take the C out the front when C doesn't depend on I. Then this is basically the exact same thing. Even though there's actually no I here, you can take any constant that doesn't depend on I at the front, so in our case, the 3. So kind of unsurprisingly, you just end up timesing the entire thing by 3. So if you want to keep kind of strictly to the math, we can put the 1 out there, put the 3 out here, and keep I equals 0 and n over 2 minus 1. Now if we remember our other formula, we've got it is from I equals L to U of 1 is equal to U minus L plus 1 is kind of the long way, and usually that just came out as U because minus L when L is 1 is minus 1 plus 1, which is 0. But in this case it's not slightly. So if we expand that out here, we end up with 3 times, so U is n over 2 minus 1 minus L, which is 0, minus 0 plus 1 is equal to 3n over 2. So obviously we've got minus 1, minus 0 is nothing, minus 1 plus 1. And this fundamentally is why it absolutely does not matter if you go from n minus 1 traditionally, from 0 to n minus 1, or from 1 to n, because in the case of 1 to n, you end up with u minus 1 plus 1. In the case of 0 to n minus 1, you end up with n minus 1 minus 0 plus 1, and the minus 1 plus 1 cancels out anyway, which makes sense because they're the exact same number of iterations. But so our answer here is just 3n over 2, which makes perfect sense because if you think about it, how many times is this iterating? Well, we're going to n over 2, and we're doing 3 operations each time, so 3n over 2. So all relatively simple. Just wanted to show an example where we actually unpack something that looks a little bit different from an actual function.